All right, let's go over formalizing relations and functions. So let's start off with a type of function machine. So this is the function machine for f of x. And we could say f of x is x plus 3. So this just means that our function is dependent on the variable x, which could change. So if we made a table of x values, and out would come y values. So for example, if we put 0 into here, put 0 into the function, we'd have 0 plus 3, and out would come a 3. So when x is 0, the function is 3. Because in this case, we would have f of 0, which means 0 goes in for the x. So instead of x plus 3, 0 plus 3, which of course is 3. If we put 1 into here, we would do f of 1, we do 1 plus 3, and out will come a 4. So when x is 1, the function is 4. And if we put a 2 into here, we would do 2 plus 3 and get 5. And we keep on going. If we did 3, be 3 plus 3, we get 6. We put 4, 4 plus 3, we'd get 7. So for a function, we put in an x value, and we end up with a y value or an f of x value. So that's important for functions, is that when we put in an x value, we get at most one value for the function. So when we put in 0, it's not 3 or 5, it's just 3. So let's look at this on a graph. So if we look at this graph, we can plot those points we had. So when x is 0, the function is 3. So this is when x is 0, the function is 3. When it was 1, we had 4, 2, 5, 3, 6. So when x is 0, this is 3. When it's 1, it's 4. When it's 2, it's 5. When it's 3, it's off the chart, it's at 6. If we put negative 1 in, we'd have negative 1 plus 3, that's 2. Negative 2. Negative 2 plus 3 is 1. And it'll continue over here also. So negative 1, 2. Negative 2, 1. And we just keep on going. Negative 3, 0. This is going to be a function that looks like this. This one happens to be a straight line. So it's defined for a lot of points, not just the points that are dots. So like for example at 1.5, we see that the answer would be 4.5. And that's because 1.5 plus 3 is 4.5, so it would match up. And for example, if it was 1.05, we would put that in, and we get 4.05. So 1.05 would match up with 4.05. Alright, so this is just one example of a function. Let's look at some more. So let's sketch the function f of x as x squared. Looks something like this. And if we look at the function f of x is the square root of x, it will follow something like this. So what's important about these functions, what makes them a function, is that when you have an x value, so this x value for example, go up, we get an associated y value. So in this case, if this is 2, this would be 4. And likewise here, if we have a certain y value, say 9, a certain x value 9, we see the function, the value of the function, or the y value, would be 3. And I got this because if you put 2 into the function, so f of x is x squared, f of 2 then would be 2 squared, which is 4. And that's how we get the graph. So here, f of x equals the square root of x. So the function when x is 3, the function when x is 9, so f of 9 gives the square root of 9, and that's 3. So x is 9, the function is 3. And again, notice we only got one y value, one function, a value for each x value. So that brings us to the next thing, which is the vertical line test. So the vertical line test is how we could look at a graph and tell if it's the graph of a function or not. So let's make some functions here. So let's start with the one we just had, the x squared. So at any x value, there's only going to be one y value. So a way to test that is with the vertical line test. If you draw a vertical line anywhere here, it only intersects it in at most one spot. So here's one spot, draw a vertical line, one location, and anywhere you draw it, it's only going to intersect it in one location. If we did this graph again, the square root of x, and we test it with the vertical line test, we see that if we draw a line here, it only intersects in one location. If we draw it here, only one location. If we draw it over here, it doesn't intersect at all, but that's okay. It can intersect 0 times or 1 time. It just can't intersect more than 1 time. So if we look at a graph like this, let me check out the vertical line test. So if we draw a vertical line here, it only intersects once. If we draw it here, it intersects a bunch of times. 1, 2, 3 times. So that means for this x value, there are 3 different y values. So this one is not a function. So let's look at a couple more. So here we have the graph of a circle. We see if we draw a vertical line here, intersects in one spot where it's tangent. But if we draw a vertical line here, for example, it intersects in 2 spots. So this one is not a function. This is a special graph. It's the absolute value graph. And we check the vertical line test here. Intersects once, intersects once, once, once. This one is a function. So remember, for each x value, you can only have one y value. So each x value, we see the function only exists at one y value, so this is a function. Here, at different x values, we have more than one y value. So like, at this x value, we have this y value, and we have this y value. And that'll match up with our vertical line test. If we draw a vertical line through that x value, we have 2 intersections, so we have 2 y values. A relation may have more than one y value for each x value. So a relation, different than a function, may have more than one y value for each x value. So if we look at this, we have 2, 1, 3, 5, 4, negative 2, 0, 1, and 2, 3. So we see that x value 2 came up twice. So in this relation, when x is 2, y is 1, but also when x is 2, y is 3. So this one is not a function, but it is a relation. If this was different, if this was, for example, 6, 3, then it would be a function because we don't have any repeated x values. But since 2 is repeated and there are different y values, it's not a function, it's a relation. So this is not a function, but it is a relation.